Hi everyone, Dr. Anna here, and today we're going to start talking about the third module of the historical geology sequence, and it is origin and environment of sedimentary rock. So let's jump in. Environments. In historical geology, our goal is to explore the Earth's long history. We've discussed the geologic principles. We have discussed some about the fossils as well. And you probably can see it by now that we use these tools to piece together the puzzle of our planet's past. Why is it so important to read the rock record? We want to understand ancient environments. We want to figure out past climates and we want to reconstruct all geography, which includes latitude and altitude. So that's why it's important to know about the different environments. On this slide, I showed you the hypsometric curve, which shows you the whole Earth and the different environments on it. The highest point on Earth is Mount Everest, and it's 8,848 meters. The lowermost point is the Mariana Trench. Probably you don't know it, but I want you to know it. It's 11,000 meters. As you can see, most of the continent is not that high, obviously. Most of it is actually pretty close to the sea level. Today, 29% of the Earth is continent and 71% is covered by ocean. Even though some of this area is covered with water right here, what we call it the continental shelf, it's right here. See, this area is underwater, but underneath of it, it has continental crust, which is really interesting. So sometimes that actually is not covered with ocean, and that's when the continents are much larger than they are today. So this area is the shelf edge, and that is what shows you the continental crust boundary. On the right side, it's all oceanic crust. Now, as we go down deeper into the ocean, we're going to have the continental slope, the rise, the abyssal plain, which is most of the ocean. It's about 5 kilometers deep. And then the trenches, which Mariana is the deepest, as you know. So this here is what we call hypsometric curve, and we're going to talk about all these places. So just before we jump into the talking about the different environment, let's talk a little bit about ecology. I know it's not a biology class, but still, even in historical geology, we need to know about the life fossils. Learning about fossils, you kind of have to know how the ecology has changed through time. I think it's very important because then you can observe evolution and a lot of other very important things about the Earth history. What is ecologic niche? Essentially, it is the sum of all activities and relationships species have while obtaining and using the resources needed to survive and reproduce. That's the most important, reproduce and, of course, survive. If you don't survive, you cannot reproduce. So, species niche includes the habitat. Where does it live in the ecosystem? The relationships, all interactions with other species in the ecosystem, and the nutrition. Basically, it is method of obtaining food. For example, if you see fern, you know that means it's a humid climate. If you see cacti, on the other hand, that you know that it's desert, it's dry condition. Now let's talk about the communities of organisms. Population of several species living together are called ecological community. In these communities, the eating habitat depends on the food chain or food web in the given environment. The organisms of a community and the physical environment they occupy is called ecosystems. Probably you learn a lot more about this in biology, and I'm not really expert in this part, but still, we have to go through. Okay, the animals of the ecosystem are called fauna, and the plants are called flora. Don't mix that. This describes the number of species that live together in an ecologic system. It is nothing else but the account of the number of different specimens present. So if you think about Smith Mountain Lake, does it have a high diversity? You might see a lot of the same fish and you might see a lot of the same little clams. It's only just like 5 or 10 species altogether. So it is very low diversity. If you think about the Arctic, that will have also low diversity, or the desert as well. But if you think about the tropical rainforest, it will have high diversity. So this is really important to know because you can learn a lot about the environments and the climate of those environments by knowing the diversity. This one here is the biogeography, the distribution and abundance of organisms on a broad geographic scale are studied within the field which is known as biogeography. Of course, this has limiting factors. What are limiting factors? If you think about the temperature, there are some animals or plants who can only live in polar environment. Some can only live in equatorial environment. Of course, more species are adapted to the tropical region because that's where the diversity is the highest, much higher than the polar regions. You could also have land barriers if we're talking about aquatic uh, forms, things which like to live in water. Then the land is a barrier. But if they are on land, then the ocean is a barrier. So you understand that. So let's start with the terrestrial realm. Basically, we are on the continent. Remember, ET was extraterrestrial. So now we're talking about the terrestrial, which is the continent. So this is the fauna and the flora of the continents. Today, it's very hard to say, but today you think the sea level is high, but in real life, if you look at the Earth history, the sea level is lower than during most of the Earth history. And the world has a very steep temperature gradient. Why? Because we have ice on the poles, and then at the equator, it's tropical. So therefore, it's a very steep temperature gradient. And of course, the climatic conditions have a very important influence on the distribution of organisms on the land. It is remarkable how closely the distribution of terrestrial vegetation will correspond to the geographic pattern of climates. This correspondence, coupled with the fact that the plants are dominant producers for food web. These are the climate zones you will have to know in the terrestrial or the continental realm. Tropical humid climate, which is the rainforest, arid climate, which is the desert, savanna, Mediterranean, the temperate forest, evergreen forest, tundra, and the Arctic. So these are the ones we're going to talk about. So let's jump in. First, let's talk about the rainforest. The rainforest will locate 20% north, 20 degree north and 20 degrees south. Don't forget, it's not only north, it's also south. So it's this 40-degree wide zone. This is the rainforest. Okay, I got a movie about it.
Tropical rainforests are some of the most productive and oldest ecosystems on the planet, some surviving close to 70 million years old. Mainly found between the tropics of Cancer and the tropics of Capricorn. These ecosystems cover only around 6% of the Earth's surface, but hold over half of the world's plant and animal species. The rainforest can receive anywhere from 80 to 390 inches of rain each year. The largest rainforests surround the Congo River in Africa and the Amazon River in South America. It is home to over 40,000 plant species, 1,300 bird species, 3,000 species of fish, 427 mammals, and 2.5 million different species of insects. The Congo rainforest is home to some of the most endangered and recognizable rainforest animals, like the mountain gorillas, forest elephants, and chimpanzees.
So, in the rainforest, the average temperature is between 18 and 20 degrees Celsius or 64, 68 Fahrenheit or higher. Latitudes between 20 north and 20 south. Very high diversity, as you could hear in the movie. The rocks in such an environment are chemically weathered, extremely weathered. So the soil zone is really, really well developed and very rich in nutrients. That's why the diversity is so high in this environment. The next one is the tropical desert. The tropical desert is 20 to 30 degrees north and 20 to 30 degrees south.
Welcome to the captivating realm of hot deserts. First things first, let's talk about the elephant in the room, water. Or rather, the lack of it. These barren landscapes are the definition of thirsty, with barely a drop to spare. But there's a certain beauty in their stark simplicity. Now, you might be wondering, why are these places so hot and dry? Well, it all starts with the intense solar radiation near the equator, causing warm, moist air to rise like a hot air balloon. As this air cools off in the upper atmosphere, it drops its moisture like a bad habit, creating those tropical rainforests we all know and love. That air has to go somewhere, and it ain't sticking around the equator forever. It starts moving toward the poles, and when it finally descends back to Earth, it's like a moisture vacuum. The warm air can hold on to more moisture than a camel's hump, so any leftover water stays locked up tighter than a bank vault. To make matters worse, these descending air columns create high-pressure zones that compress the air, cranking up the heat like a giant oven. It's like the atmospheric version of a pressure cooker. And if that wasn't enough, the high pressure acts like a bouncer, keeping out any party-crashing storms or rain clouds. So, what do we end up with? A recipe for the ultimate desert climate: cloudless skies, scorching temperatures, and rain that's as rare as a snowflake in the Sahara. It's like Mother Nature's version of a practical joke. These desert regions come in two flavors: the true hot deserts, BWH, and the hot semi-arid steppes, BSH. The difference? One's as dry as a bone, while the other manages to squeeze out a tiny bit of rain, just enough to support some tough, stubborn shrubs that refuse to give up. Now, let's take a virtual trip around the world and check out some of these hot and dry hotspots. In the United States, we've got the Mojave Desert, stretching across Southern California, Nevada, and Arizona. It's like a giant sandbox for grown-ups. Head south, and you'll find yourself in the Sonoran Desert of Mexico, where the cacti stand tall and the heat is always on. But if you really want to experience the king of all deserts, look no further than the mighty Sahara in Africa. This behemoth covers practically the entire northern part of the continent, making it the largest hot desert on the planet. It's so big, it could swallow up all the other deserts and still have room for dessert. The Sahara's influence extends into the Middle East, too, covering the Arabian Peninsula and parts of Iran, Pakistan, and even India. It's like a giant, sandy blanket that just won't quit. Down in southern Africa, the Namib Desert hosts some seriously cool coastal fogs, while the Kalahari Desert invites you to unleash your inner adventurer. And let's not forget about Australia, where the vast majority of the continent is one giant desert party. The Red Heart of Australia is home to a bunch of smaller deserts with names like the Great Sandy, Victoria, and Gibson. So, what kind of scenery can you expect in these hot and dry climates? Well, plants are few and far between, but that just means you get an unobstructed view of the Earth's rocky bones. The wind plays sculptor, carving the rocks into mesmerizing sand dunes that stretch as far as the eye can see. It's like a giant Zen garden, minus the rakes and tiny bridges. In areas with a smidge more rain, hardy shrubs dot the landscape, spaced out like they're practicing social distancing. And let's not forget about the most famous desert dwellers of all, the cacti. These prickly pals have adapted to survive in a world where rain is as rare as a unicorn sighting. They hoard moisture like it's going out of style, making them the camels of the plant kingdom. So there you have it, the incredible, scorching world of hot deserts.
So, the tropical desert between 20 and 30 degrees north and south. For example, the Sahara. Diversity is extremely low. You only have like a couple of scorpions and some people looking for water, or some animals. Extreme temperature difference during the day. Sometimes it's like 118, and then at night it's negative, minus 10 degrees Celsius. The sediment here only physically weathered, mostly sand transported by wind. So you see beautiful sand dunes, ripple marks on the sand dunes. It's beautiful. Maximum 20 inches of rain per year. Sediment here only physically weathered, mostly sand transported by wind. So you will see beautiful sand dunes with low ripple marks on top of them. Sometimes it's big sandstorm when the wind is really strong. The sand will just kill you. It hits you in the face, and the quartz pieces are, 7 in the hardness, so it really cuts your face almost. It can also occur in other latitudes, such as mountain shadow in Arizona, for example, in Oregon, or far, far away from the ocean, like the Gobi Desert. When an area is completely surrounded by other continents, in the middle, it's going to be very, very arid. So it's come on like in the Gobi Desert. This here, a couple of pictures of typical tropical desert. One of the best example for tropical desert is the Death Valley. Geologically, it's very interesting because it's a typical graben fault which forms when the continents are pulling apart. When the continents are pulling apart, the graben faults are facing each other, typical normal faults, as we learned in physical geology. The normal faults characteristics is that the hanging wall moves down, and when they are facing each other, that basically is making a base which is lower than any other area in the neighborhood. So that's why the bottom of that valley is below the sea level by 280 feet. And the sedimentation is so quick during these times because the rivers could not go up to enter the ocean, so that the bottom of the basin has to reach sea level quickly. Every spring there is a little bit of rain, and that rain makes a lake on the bottom of the valley, and this lake is starting to evaporate basically right away, and it will have a lot of sodium chloride, of course, but other chemicals as well. That's why they can mine borax in that valley. You probably know about borax because in physical geology you had to make borax crystals. Oh, I think it's time to stop the first segment, and so we're gonna go to the savannas in the second segment. I will see you there.